Today's preparation is about capitalized cost. Here's an example to get us started. A tractor pull has an endowment. That means money that's invested to support a project using only the interest that's earned on that investment. You're not allowed to spend any of the principal amount or the original investment. So for example, if they started with $100,000 in their endowment, then they can take out whatever interest they earn. Maybe that's $5,000 in a year, $10,000 in a year. Whatever they earn, they can take out. But they cannot take any more than that out. They have to maintain at least $100,000 in that account. So Tractor Pull gives out scholarships every year at the BRAE banquet, and so you might ask, assuming that the interest rate that they earn is 10% and that they want to give out $30,000 per year, how much principal are they going to need in their endowment? Let's go ahead and solve that. So this is just an introduction to capitalized cost. We haven't even used the term yet, but it turns out to be equivalent, these problems. So let's go ahead and solve this. All right, so they have, they want to get out an annuity, right, which is $30,000 per year. They have a principal. We don't know what that is. We're not sure what that is. We're trying to find that. So we know, though, that that annuity that they want to take out is whatever the principal is times whatever their interest rate is. And their interest rate is 10% per year. So we can find out what the principal is just by solving this equation. P is equal to A divided by I. That's the amount of money that they're going to need so they can take out A in interest every year. All right, so let's figure that out. 30,000 divided by 0.1 is equal to $300,000 is the amount of money they initially have. So actually what we found here is that, take a look here, that with this interest rate, look, we've got a P over A factor is 1 over I, and A over P factor is equal to I. And these are the discount factors if you want to convert between an annuity and a principal amount for infinite life, for N is infinity years. These are kind of like the discount factors. This here is the first one, the discount factor P over A, given I%. For N, it's the limit as N approaches infinity, is kind of a way to think about it, is equal to this here. And this is the inverse of that. All right, so let's talk a little bit about capitalized costs now that we know about those factors. The present worth of a project with infinite life is one way of looking at it, because we just found that we could basically get a discount factor that converts an annuity forever to a present value. And so that's one way of thinking about it. That's the definition of capitalized cost, is the present worth of a project with infinite life. And the other side of the coin is that it's the amount of money that you're going to need at an initial time, say in your endowment, to perpetually support the project only on earned interest. These are two sides of the same coin. So here's one way to think about it. It's the limit of this discount factor. This is your discount factor corresponding that you're going to need to calculate a capitalized cost. It's just 1 over I, and so here's how you can calculate the capitalized cost. It is whatever the annuity that you need is divided by the interest rate. And I bet we could take the from a table, right? There's a table that shows us the formula to calculate P over A for a given I and a given N, right? If we took the limit of that as n approaches to infinity, I'm sure that mathematically with calculus we'd find this. I think we'd also find, you can try this on your own, go into the discount factor table that I gave you and plug in n is 100 years, n is 1,000 years, n is 1,000,000 years, and I think you're going to find that the P over A factor is going to converge to 1 over I. And you know, the other side of that coin is that the A over P factor is going to converge to I. So take a look and try that yourself, convince yourself of that. Let's do one more example problem. Oops. One more example. By the way, before we get to this example, I should mention that this annual cost could be calculated according to an equivalent uniform annual cost. It's not necessarily the case that you have to take out only that amount, exactly that amount every year. All it needs to be is an equivalent uniform annual cost. And so we'll see an example of that on the next problem here. So you decide that you want to hold your company's domain name, zonsteer.com, forever, and you're considering how to pay for it. So you already bought it this year. That's all taken care of. What you're trying to decide is what to do for the future. So normally it costs $12 per year to register. That's what you already paid this year, is $12. But you can register for 10 years at a time for $100. And your question is, assuming your country investments earn 10% interest, which of those two options is the better deal for your company? And what is the capitalized cost? Actually, what we're going to do is we're going to calculate the capitalized cost. We're going to look at the capitalized cost. Because you want your domain name forever, the capitalized cost tells you what is the present value of all those infinite future payments for your company's domain name, whether you're paying $12 per year or if you want to pay for 10 years at a time for $100. And initially you think, oh gosh, this is the better deal, right? I'm paying for only $10 per year instead of $12 per year. How does the interest rate affect that calculation? So let's go ahead and solve this one. All right, so in this case, so there's two options here. We have option A, and that is annuity is $10 per year. So actually we can calculate the capitalized cost for that one real easily. The capitalized cost is whatever that annuity is divided by our interest rate. So $12 divided by 0.1 is equal to $120. So if we had $120 in the bank today and we accrued 10% interest, then we'd have, at the end of the year, $132. We could take out this 12 and we'd still have 120 left. And so we could keep on doing that. So this is the capitalized cost of our option A. Option B. So we don't know immediately what our annuity is. We know that every 10 years we have to pay 100. So what we want to do is calculate the equivalent uniform annual cost. So the first step in calculating the equivalent uniform annual cost is we need to calculate the net present value. So the net present value of this investment, which is 10 years long, is that $100, because we're going to pay for that immediately. The equivalent uniform annual cost is the net present value multiplied by a discount factor. So the discount factor in this case is the A over P, right? For whatever the interest rate is over the period of the investment. This is 10 years, or N. I'm going to go ahead and just indicate this here is 10%. And we're talking about a 10-year investment here. So let's find that discount factor. All right, plug that into our handy dandy discount factor table. 10% interest rate, we have 10 years. We need the A over P value. A over P is this column here, 0.1627. Okay, so this is equal to 100 times 0.1627 is equal to $16.27. And step 3, we calculate the capitalized cost as whatever the annual amount is, the EUAC in this case, over the interest rate. So 1627 divided by 0.1 is equal to 162.70. So it turns out the capitalized cost for this plan is going to be more expensive than the capitalized cost for this plan. I think that we're going to want to go with option A.